If you guys remember how to add fractions together, that would be an awfully big help. If I have two fractions, 1/3 plus 1/4, those denominators are not the same. So what I need to do is multiply the denominators by something called crazy, I messed that one up, by crazy ones to make sure that they're going to look the same now. On the left, I would have 4/12. On the right, I would have 3/12. That's going to add together just fine. Well, that's great, but it gets a little more complicated when you have all these equations in your fractions. So look at what I'm going to do here. First of all, let's address this right there. That's dangerous. That negative sign outside the fraction needs to be distributed into the entire fraction. And I'll bet half the time that's what the mistakes are if you're wondering what went wrong. This is going to be a negative 4w plus 6. Okay, in the denominator is w squared. And then I'm adding another fraction, 2w plus 5. That's fine, but its denominator is what I care about. That's going to be w times w minus 4. And I'm factoring this out on purpose because I want to see what exactly those denominators have that maybe is not common. Okay, if you look at this denominator over here, that's a w squared. The one on the right does not have a w squared. It has a w and a w minus 4. So we're going to multiply an extra w into that one. And this one on the left side, what's that missing? Well, it's missing the w minus 4 action. So that's going to be w minus 4 and w minus 4. Okay, remember everything's in parentheses. This is all multiplication that's happening here, so just be careful how you write that. Okay, distribution time. Let's multiply these bits all together. And what I'm going to do is treat it like this, where w multiplies to the negative 4w and then to the 6, and then the negative 4 will do likewise. So on top, on the left, what I get is negative 4w squared plus 6w minus 16w and minus 24 from the looks of it. Okay, and the one on the right is easier. That's just going to be 2w squared plus 5w. And now we look at the denominators, realize those are just a common w squared times w minus 4. And this is a single fraction, which is great. That's what I wanted. I wanted to have a single fraction, and I want to simplify it now. That's kind of an important part. We're going to simplify this as much as we can. So what I'm looking for now is common factors. And you see right here, or not common factors, common terms. I've got a negative 4w squared and a plus 2w squared. So that's going to turn out to be a negative 2w squared on top. And then the next thing that we're going to look at, let's talk about the w's. This is a plus 6w, a minus 16w, and a plus 5w. So if you count those all up, we're going to get, I think, negative 5w. And then there's only the negative 24 left, so you just stick that on there as negative 24. Okay, of course, it's all over w squared times w minus 4. Now what's left? We still have one step we have not done yet, which is factoring anything remaining. You should always do the factoring step because for all you know, there might be some terms on top that cancel with the terms on bottom. But I'll save you some time and skip to the chase. In this particular one right here, we cannot factor that. Okay, I could try GCFs, that fails. I could try grouping or trinomial factoring by a big X, whichever method you like. You're not going to be able to factor that. This is called a prime polynomial, meaning that's as simplified as you can get it. And now if you compare the top and the bottom, you see there's no common factors. And when there are no common factors, that means no canceling stuff. Okay? We do not want to cross out a w from the left sides of this thing. That would be crimes against mathematics. So please don't do that. Just leave this in simplified form. That is as far as we can get it.